Hey, so this is our last unit on, or this is our last lesson for this unit on angles and lines. So we've talked about lines, how to name them. We've talked about angles. We've talked about triangles and the exterior angles. So we want to go beyond triangles now and start talking a little bit about polygons. So let's take a look at some polygons and what we can do with those. Okay, let's take a look at our problems here. We've been talking about triangles, which are one type of polygon. They're the simplest. And that brings the question, well, what is a polygon? Well, a polygon is a figure that has segments for sides closed and multiple sides. Okay, so we got to have segments. You can't have a curved side or anything like that. You got to be closed. You can't have a polygon that has one side opened up or something like that. And multiple sides. 3 is the least number of sides, and it goes up to infinity from there. So some common polygons that you probably know. We already talked about triangle, 4 sides quadrilateral, 5 sides pentagon, hexagon, heptagon, so forth and so on, dodecagon, and this can go on and on and on. There's really no real ending to how many sides you can have. So a regular polygon is a little special because a regular polygon is a polygon with all sides congruent and, that's a big and there, all angles congruent. So like our equilateral triangle is also equilateral. That means it's a regular polygon. But a rectangle is equiangular, but not equilateral. A rhombus is equilateral, but not equiangular. A square is both. So here's some examples of regular polygons. The pentagon that we're used to in Washington, D.C., that's a regular polygon. So moving on with that, since triangles are the easiest polygon to deal with, we tend to take our problems and break it down into triangles. For example, we want to find the sum of the measures of the interior angles of this polygon. Well, again, triangles we know sum to 180. Beyond that, you might know quadrilaterals, but this is a pentagon. So we got to break that down. Well, let's break it into triangles. So if I go from E to C and from E to B, I've created 3 triangles. And I know these angles all add up to 180. So I get 180 in that triangle. And the same thing here. Those angles all add up to 180. And these angles all add up to 180. So when I start putting all these angles together, this one, this one, this one, that one, that one, and that one, and here, and here, and here, I end up getting 180 3 times. Oh, well, that's pretty easy. That gives me 540 degrees. That's the sum of these angles. Okay, now how do we get, why 3? Well, there's 3 triangles. Yeah, but how can I get that without having to draw triangles in there? Well, let's see. We know this thing had 5 sides. How do I get from 5 sides to a 3 in this position? Okay, well, how would you go from 5 to 3? Subtract 2. If I do 180, 5 minus 2, well, that should give me my 540 degrees. And that's the sum of these angles. Well, that's kind of nice because that leads us to a formula. That formula that we're going to deal with leads us to a formula that works for any polygon. If I've got n sides, then our formula, we just said it was 180, the number of sides minus 2. This is the sum of the interior angles. So all the inside angles added up, where n is the number of sides. So now, if you had a 20-sided polygon, you could plug that number in here and figure out how many degrees all the angles add up to. Here's a bonus, if it's a regular polygon, then each angle is this number, whatever that is, divided by the number of sides. So like our our pentagon, for example, was 540. If I divide that by 5, I'll get how big each angle is. Okay? And we'll talk about that as we get near the end. Now, that's all interior angles. That's the angles inside the polygon. Here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. This looks like a decagon. So I could figure out how many angles on the inside of this. But what about the exterior angles? We talked about the exterior angle of a one second, audio. Whoops, got some choppy audio going on. So hopefully you got some of that. We talked about the exterior angle of a triangle being the exterior angle times the sum of the remote. Well, there's too many remotes here. So when we're dealing with this, the sum, this is easy. Can't assume they're all congruent. The sum of the exterior angles of any polygon is 360 degrees. No matter how big the polygon is. Triangle, 360. Decagon, 360. They're all the same. So that means we could now build a chart. So this is your first piece of work. You're going to have to build a chart that does this. Pentagon has 5 sides. The sum of the interior angles. So that's 180, 5 sides minus 2, and we said that gives us 540. Each angle, because it's a regular polygon, I can actually compute each angle of those. So I'm going to take that 540 for the sum of them and divide by 5 sides. And when I do that, I get 108. Each exterior angle, well, all of them together add up to the 360. So if I take 360 and divide by 5 sides, well, that gives me 72 degrees for each angle. What that's going to tell me is if I've got a regular pentagon, I'm drawing a very terrible regular pentagon here. There we go. Each angle inside here is 108 degrees. Whoops. But if I extend each of these, each exterior angle is 72 degrees. Oh, look at that. 108 and 72. What's it add up to? That's right, 180. So it's a pretty simple process. Okay? So now, fill out one of these charts and answer a couple more questions. Okay?